All yours, David.
Thank you very much. So I'm David Gilder, CEO, co-founder of Data Who here knows Data I'm just interested. A few people don't. So basically, we're a monitoring company for enterprises, microservices, and cloud. So if you're doing cloud microservices monitoring in a big enterprise, we're the monitoring solution for you. And we're a little bit different from all the other monitoring companies out there. We're actually a monitoring company with a mission. And we're on a mission to make monitoring great again. Not just that, but we do plan to build a wall. We want to build a wall of dashboards, and do you know who's going to pay for it? Developers are going to pay for it. Those developers that deploy that shitty code into production that wakes us up at 3 AM in the morning. Those developers that basically always focus on the functional requirements and don't give a shit about those non-functional requirements that scale the service. And yes, those .NET developers that make us deploy Windows into our production environments. But I'm afraid to say, a few of them are code molesters, some of them are servers, and some of them bring illegal null pointer exceptions into our environments. So, anyway, so look, in the next 20 minutes while I do this talk, if you guys want one of these hats, they're limited edition, they're literally the last 10 hats I have, I've got them in a bag at the back. Just sign up on that URL over there. I want to see how many sign-ups you can get in the next 20 minutes. If you sign up there, there'll be a hat for you at the back at the end of this talk. So come and join our campaign and make monitoring great again. So anyway, more seriously, we also are the organizers and co-founders of DocSlung, and we're going to be doing our next meetup on Monday. So essentially on Monday we're going to be doing a whole meetup on AWS Lambda, talking about serverless and how to use Lambda, and some companies like Just Eat, AWS and Financial Times talking about how they're using it. So if you feel like 2 meetups in a week's space, then come to that one. Generally we have them a bit further apart from these guys, but it just happened with holidays and events. Anyway, so let's get started. So I'm going to keep this pretty high level because, one, it was a last minute talk, so I had to kind of take on my sales slides and kind of do that. But the second thing as well is, I know you guys are pretty technical and stuff like that. I feel like there's a lot of blogs on monitoring microservices that are very technical, so I'm going to kind of bring it up a level to kind of the vision for microservice monitoring and kind of how it should look in a kind of microservices environment. So who here kind of knows what microservices is? So most people in the room know what microservices is. So just for those that didn't put your hands up, microservices is an increasingly popular architecture for not just basically scaling your online services, but also for organizing your teams around. So if you look at Spotify, they have about 26 product teams, Fullstack Teams that basically own over 100 microservices, and each team will own a collection of the microservices. So there'll be one team that focuses on the playlist functionality, there'll be another team that focuses on the search functionality. And all these microservices kind of do discrete kind of functions in the application, and they kind of all talk to each other, and then build your kind of Spotify app that as you as an end user end up using. It is pretty much a way of organizing your teams and members around the software architecture. What it isn't is it's not Docker. Docker is a component of microservices, but it's not microservices. A lot of people kind of, it's got very tied to microservices, but it is not microservices. It's just a component technology to kind of help you with that. So I think when we, the things I'm going to be focusing on is really around the people, because it's all about full stack teams and self-service. Because a lot of monitoring tools out there, they focus on kind of how do you monitor Docker, how do you monitor microservices, how do you trace transactions between them, but they haven't focused on the people side of it, of how do I have multiple teams that own different parts of my infrastructure, still have that top level visibility, and still allow these teams to get the monitoring that they need for all their different services. So when you look at it, when you move into microservices, you literally have operations moving more into a platforms team like this, and providing those common tools and processes to all your microservices teams. And the great thing about microservices is these guys now have complete autonomy over what technologies they use to build that service. If they want to build something using Elasticsearch, they can do that in an ideal environment. They can manage their own services and environments. And all that stuff we were talking about just now about how to get developers to kind of support their own code and stuff like that, this model relies on developers supporting their own code in production. They deploy it, they have to support it, they have to monitor it. So now monitoring isn't now just a platform responsibility, It's a team responsibility across all the different microservices. So the key thing, if you take nothing else away from today, is it is all about self-service. It has to be completely self-service. And I kind of compare it to kind of a checkout stand at a supermarket. So you can see the person at the back who's kind of just there. That's really the platforms team. So you've got all your teams basically checking out and doing their things, and then platform team really only steps in if there's an issue. If they want to buy alcohol, come in, approve it, done, kind of thing. But essentially, that's how the microservice monitoring has to work. It has to be something that you just give to the teams. They do it all by themselves without you having to step in unless there's a question or a query or something that's more service-wide. And the problem with most monitoring tools today is they've all been built with this kind of centralized concept. And this doesn't matter if it's the open source tools or the newer SaaS tools. You may know some of our competitors. They've all pretty much built their products around this kind of centralized model where operations tend to have to do all the setup and configuration for the entire monitoring stack. So yes, developers can go in and create their own dashboards and alerts once they've got the data in, but to collect all that data, to set the monitoring across all your different servers, environments, all that kind of stuff, that tends to be an ops kind of role. And what some maybe further along organizations have done is they've written loads of configuration management so that developers can contribute to that configuration management so that they can help with that kind of first task of collecting the metrics and the data. But generally, most organizations are kind of stuck with ops doing this and everyone else kind of using it. So then what happens, and this is what we see commonly in most of the organizations that we go to, you see this more decentralized monitoring. So you end up with large organizations where they end up having all these silos. So this team over here we use Graphite, this team over here we use Prometheus, this team over here we use this, and it becomes like a mess basically. And this is actually the common scenario that we enter in when people use data loop, we kind of replace all this stuff. But this is a very common kind of scenario. And we all know the problem with silos. You get the high priest of monitoring, who basically comes in and says, this is my monitoring tool, and I'll give you access to it if you really want it. So really what we want is we want to combine the two. We want to have a more centralized thing because we still need to see the entire visibility across the entire service, but we still need to give those teams the monitoring that they need at a team level kind of thing. So, so essentially that's really what we want to combine. So when you're thinking about your monitoring for microservices, you want something that can be given to the teams as a complete self-service solution, not just the dashboards and the alerts, but something that can be configured by them as well and deployed by them without you having to do anything in a standardized way, while you still have that kind of top-line visibility across the entire service, because everyone needs that, at least the operations team need that so they can see what's going on. But let's say you actually build that type of tool or you buy that type of tool or whatever. The next problem is you can have the best tool in the world, but if no one uses it, who gives a crap? You need to get adoption. And the number one issue with getting adoption in any tool is generally friction. Friction in is hard to use. Friction in is hard to set up. Friction in, it takes a minute for my graphs to load or something like that. You need to think about all these kind of things that are going to stop people from using your monitoring tool and is going to make them go off and install a Prometheus or Nagios server by themselves without you guys having any control over it. And so we think a lot about adoption, and especially when in the world of microservices and DevOps, your monitoring stakeholders aren't just developers and operations anymore. Your product owners are using monitoring. Your QA people are using monitoring. Your business may be using monitoring. And so you've now got all these less technical stakeholders where if you gave them a Nagios install and said, oh, there's your graph for availability for the last week, they're not going to use it. You have to basically think about how you're going to get these less technical users using it as well. So when you're thinking about friction, I'm going to bring into play this concept called an OODA loop. So, does anyone know what the OODA loop is? A couple of you have seen it? Yeah, it's a very cool concept. In fact, data loop comes from this name, data loop. So data loop pretty much came from OODA loop. It was either that or OODA daddy. So basically, there's four kind of parts of it. So basically, in the 1950s, a US Air Force pilot came up with this concept. It was a way for kind of training pilots in the US Navy on how to win dogfights. If you could observe what was going on, orient yourself into the best position, make a decision and take action quicker than your competitor, you'd win. And actually, when you think about this in a technology thing, if you look at high-frequency bank trading, this is the ultimate OODA loop. It observes all the metrics coming in from the stock market, it kind of makes decisions using machine learning algorithms in like milliseconds, and takes action by booking trades in like milliseconds. That's kind of like the fastest OODA loop. But if you look at OODA loops, you see them everywhere. Facebook doing 10,000 experiments every day at any one time across their platform. Amazon does 20,000 deployments every day, iterating things, iterating prices, and all that kind of stuff on their platform. But when it comes to monitoring, it does actually fit into the whole monitoring world as well, because that's what we're trying to do. We're trying to collect data, we're trying to make decisions on it, and we're trying to take action on it. And so really, when you kind of put it to that, Yardi, which is a large online service in the US, they kind of analyze the amount of time they spent basically on each of these stages. And if you can see, most of the time is spent in this bit. That's where the friction is. It's collecting the data that you need. That's 60% over there. And that's really a waste of time, because you're spending all your time instrumenting your apps, adding stats into your code, writing Nagios plugins to monitor this and that, deploying, writing configuration management. Once you add up all that time, if you have to spend that much time just to get that one metric you want to see into a monitoring system so you can graph and alert of it, you're going to that's friction. That's what turns people off from using your monitoring system. So they actually did a thing where they said in their ideal world it would be 10% deciding what you want to monitor, 10% collect the data, 50% actually looking at the data and actually making decisions based on it, and maybe 30% kind of doing actions on it. So really, when you look at your monitoring tool, you have to really focus on minimizing that collection step, because that's a waste of time. Like, how can you make it easy for developers to write a plugin so they can get the metrics in they want? How can you make it easy for them to push in metrics using StatsD, Prometheus, or whatever other standards out there to kind of get metrics into the system? And if you minimize that and you make it really easy for that metric to go from there to a graph to an alert, then you get adoption. And that's what we're seeing with our tool. Third problem, microservices creates more metrics. So, if you look at how monitoring's kind of evolved over the last few years, you've kind of had cloud come along. That's already very dynamic and, spinning up servers, spinning them down. It's kind of, created more metrics by default, just because you get more activity happening in your environment. Then Docker came along, so now each server, instead of just sending you 100 metrics, is now sending you back 1,000 metrics if you have 10 Docker containers on each server. It could be more than that if you're like us and you write a plugin that collects 500 metrics per Docker container, like my co-founder did. So, you basically end up collecting more. And then on microservices, not only that, you're now adding even more services and even smaller instances to the mix, so you're basically exponentially increasing the number of metrics. And what does this mean? Well, it means this is kind of what you need to build to monitor microservices at a high availability kind of thing. This is actually an old architectural diagram of Phaedra from about 2 years ago. It's out of date. We now have about 10 more services on there than I'm showing, but I didn't have an up-to-date kind of diagram. But essentially, this is kind of what you have to do. You have to build queues and caches and time series databases. You have to have front-end graphing. You have to have all these components streamed together, buses, to buffer the metrics, all that kind of stuff. This is what most online organizations, the Netflixes and the Twitters and the LinkedIns and Uber, are building internally with a dedicated team of like 5 or 6 engineers, pretty much building this full time for like 2 years. Atlas is Netflix thing. Do you know how much Atlas costs Netflix every year in operating costs to run? 20% of their operating budget goes on Atlas to collect all the billions of metrics that they go, that they have to monitor to kind of keep Netflix up and running. They joke that they're the largest monitoring company that streams movies. That's kind of where they are at. And that's like the bigger end of the scale. But when you get to 100 servers, 200 servers, when you start moving to microservices, multiple teams, they're all starting to put their metrics in, you get to something like this. So then you start having to make the choice of, do you build or buy? And if you're going down the build route, you are going to spend 6 to 12 months building something to monitor microservices, especially if you want high availability with it shared in different regions. So if one region goes down, you still have monitoring, because you need visibility in microservices. You can't run a microservice without monitoring. So a lot of this was actually the problem we had, which is why we sold a data route. We spent 6 or 12 months of our lives building monitoring, and then we decided just to build this as a service that you can install on it. But this is the thing that's happening. Thank you. So the other problem that you see, and this is kind of obviously now we're going more into the technical things, is it is increasingly more complex environments. So now if you're letting your teams choose the technologies they can use, one team may be a Python team, another team may be a Node.js team, we're an Erlang shop, so imagine monitoring that. It's basically a lot of technologies now coming into your environment, and that's a good thing, because you're letting each team optimize for what they think is the best tool for the task they're trying to do, and what allows them to kind of get these things done fast. but it introduces complexity. That's why you also have to push monitoring and support down to the teams, because one operations guy cannot understand how to run, to support Erlang and Java and Node.js and all the other kind of technologies that are going in there. You push it down to the teams so that they can do it themselves. And so really the only counter to this, which is what we've kind of followed at Dataloop, is you have to go for open source standards. Because every week there's a new technology that comes out, there's a new way of monitoring Docker, there's a new way of, maybe a new database. We've actually got our own open source database, by the way, called Dalmatina DB. We've open sourced it, does 3 million metrics per second on a single node, probably the fastest time series database in the world. It's written in Erlang. But when we launched that, there was no monitoring for that. But with the open source community, they write Nagios plugins. Nagios is a pretty respected standard that people have been doing for 10, 15 years. So if you support Nagios check scripts, most likely you're going to find something on the internet that someone else has written. If you support Graphite, there's about 100,000 different tools that push metrics to Graphite. If you support StatsD, well, there's libraries for all your main kind of codes. If you support Prometheus, which is the new one that's coming up, that's getting huge support in the community. So by going for open source standards for your collection, you basically remove all that complexity of having to build a collection yourself, all the different languages and tools and services and all that kind of stuff. So yeah, go for open source standards. Finally, who changed what? This becomes a problem. When you now got multiple, teams all changing your monitoring configuration, you need an audit trail. You need something like Git or version control to kind of see what, who changed this dashboard, who changed this alert that didn't fire up last night, oh, it's because someone changed it, who changed it, You need to start having some audit trails, just like you get in GitHub, to kind of, see what's been going on. So those are kind of the 5 top problems, that we tend to see with microservices and what we've designed Dataloop around. We do actually have a little bit more, so if you want some more insightful insights, there is an ebook that I wrote. Donald Trump's endorsed it, so yeah, you can download that too, which goes into more detail on everything I've just been talking about. But that's it. So sign up for Dataloop and get a cap, and thank you.
Thank you very much. I think the food is here. It's not that much of it. Everyone hungry? Any questions?
Oh, the book or the hat? Everyone wants a hat. Just a sec.
Nobody got a question? Right.
So I'm actually going to ask you to show another slide again. You have Graphite, StatsD, Prometheus, and they look, actually I'm not too familiar with Graphite. I'm just taking pull versus push, which Prometheus and I've been looking at DB. What do you say your own one was called again, your time series database?
Dalmatina.
Which both push and pull?
Okay, here's a slide. So push and pull. There's always a debate. Some people think push is better because it's easier for developers just to push metrics in, it's more real time. Some people prefer pull. Prometheus went for the pull model, where you have to kind of pull, you basically scrape HTTP endpoints and kind of scrape all the data from that. They have their arguments for why pull is better than push. And then some people push, and that's usually StatsD, Graphite, or InfluxDB, you can do the pushing as well. So what was your question exactly?
So you're supposed to push and pull?
Oh yeah, we support Graphite, StatsD, Prometheus, and Nagios, and we're going to be adding InfluxDB maybe as an endpoint and stuff. Basically, our vision is everything should just be open source compatible. If you want to use Telegraph from Influx to data push through your metrics to us, in fact, we're using that in our Docker container. Use it.
Telegraph to your own?
Yeah, so we have a Docker image, which basically, if you install it onto the server, it will automatically scrape all your Docker containers as they appear and come and go. And we're actually using Telegraph inside that Docker container to push the metrics to us with all the multi-dimension stuff. Because again, we're a small team. We don't want to write every single collection for Docker, for Kubernetes, for all the other stuff that's appearing. Like, let's just use the open source standards and just support the open source protocols. Boom,
Cool. Anybody else got a question? All right. Go on then.
For distributed infrastructure, do you have some kind of proxy or local center to collect data locally without distribution to the central point?
No, we don't have a kind of proxy. Well, we do have proxy built into the agent. So if you do have a proxy and you're behind a firewall and you need to put it through a proxy, we can support that. The agent also buffers metrics. So if you do go offline or something, we'll buffer them up to about 50 megabyte cap, which is usually about 2 days of data, and then we'll stream it back as soon as the connection comes back. But we don't have any kind of proxy in the middle. I mean, for large customers, we have actually set up some proxies in kind of edge locations like Asia. So we've got a customer in Australia that's running 500 boxes or something. We've put a server proxy in Asia so that they can connect locally to that instead of having to connect all the way back to us in Europe.
So all traffic is go through your center?
Yeah. We're a SaaS platform. If we'd done like the whole on-premise or anything else than that, we would have ended up having to get the customers to deploy that architectural diagram of like about 20 different tools and stuff like that, and then you're back into the world of I may as well build it myself. So no, we're a completely SaaS product.
Awesome, David Gilder, thank you very much.